Okay, so what we are going to do now is we are going to discuss about boundary value problems. Okay, so boundary value problem, remember, means you have conditions for the differential equations, but these conditions are for different x values. Okay, all right. So let me explain this from an example. Now, a boundary value problem can have infinitely many solutions or no solutions or unique solution. So let's look at some cases. Okay, so here we are given a differential equation. Okay, and I have given you the solution also. Now again, you don't need to be concerned where I got the solution. It's that I am providing you the solution. Later in this course you will know how to get that solution. Okay, so that's not a concern here. Differential equation and the solution is given. C1, C2 are constants. Now, what do we need to do? So we impose these conditions, we use these conditions so that we can find C1 and C2, right? So let's use them. So the first condition says when x is equal to -1, y is 0. So if you substitute that, y is 0, okay? So we get when x is equal to -1, y is 0. So -1 square is 1, so C1 plus -1 to the power 4 is 1, so C2 plus 3. So that means C1 plus C2, my bad, here C2 is -3. So that is how I get this equation. Okay, now you can see we cannot still find C1 or C2, right? C1 plus C2 is -3, but we can't find C1 and C2. So that is why you need two conditions, because you have two unknowns as constants. So to find C2 we use the other condition. So we substitute x is equal to 1 and y is equal to 4. If you substitute those, so what we will get is 4 is equal to C1 plus C2 plus 3, right? When you substitute 1 for x. Good. Now we take this 3 to the other side, so we get C1 plus C2 as 1. Now we have two equations, two unknowns. We can solve for C1 and C2. But hang on a minute here. Okay, do you see a problem? Look at these two equations. One equation says C1 plus C2 is -3. Other equation says C1 plus C2 is 1. That doesn't make sense, right? So according to this, it seems to be like -3 is equal to 1. Right? Because both of them are equal to C1 plus C2. So that does not happen. So actually we cannot find a C1 and a C2 here. What does it mean? Then what it means is for this differential equation and for this solution, you cannot find a unique solution here for given these boundary conditions. So the boundary conditions are not good enough. Okay, so how many solutions we have? We still have infinitely many solutions because we don't know C1 and C2. C1 and C2 can be many things, but for this boundary conditions, there's no solution. Okay, so we started with infinitely many solutions here, but here using these boundary conditions, we do not have a solution. The boundary conditions are not good enough. So let's take the same differential equation. So we have the solution y is equal to C1x cube, C2x4 plus 3. Now let's change the boundary conditions. So if you change the boundary conditions, let's see what do we get. So we use when x is equal to 1, y is equal to 3 here, and let's say we get this first equation, and we use y2 is equal to 15. When x is equal to 2, y is 15. So we use that and we get these two equations. Well, now we can solve this, right? How can we solve these two? Okay, so let's say the second equation, the 4 is common factor, so let's divide by 4. So the first equation is C1 plus C2 is 0. If you divide by 4, C1 plus 4C2 is 3, right? See? Okay. Now, what we can do is, this is the second equation, this is the first equation. Let's subtract first equation by second. So if you subtract these two, C1 cancel out, right? 4C2 minus C2 is 3C2 is equal to 3. What is C2? C2 is 1, right? Okay, we get C2 is 1. So if C2 is 1, we can use 1 here, substitute here. What does it mean? C1. C1 is -1, right? So we get C1 to be -1, C2 to be 1. So what is the solution? So the unique solution is negative x cubed plus c2 is 1, x to the 4 plus 3, right? Okay, so we were able to find the two constants, and this is the unique solution. So these boundary conditions are perfect, okay? And it gives you from infinitely many solutions to a one unique solution, okay? All right, so we learn a case where we don't have no solution and a unique solution. So let's see third case. So we have the same solution, c1x cubed, c2x to the 4 plus 3. Now let's use this condition. When x is equal to 0, y is 7. Oh, hang on a minute. If you use this boundary condition, that means 7 equal to 3, right? If you substitute 0 for x, y is 7. That does not make sense, right? So that means these boundary conditions are not good enough, right? So you cannot expect a solution. Again, this is a mathematical contradiction. 7 shouldn't be 3. So again, for this boundary conditions, there's no solution. So those are another inappropriate boundary condition. Now again, let's look at the fourth example. So we have y is equal to c1x cubed, c2x to the 4 plus 3. Okay. All right. Now let's use the condition. So y0 is 3. So when x is equal to 0, y is 3. So y is 3. When x is equal to 0, this is 0, this is 0. So 3 is equal to 3. So this is the equation we get. Well, that's true, right? Good. So nothing helpful, right, from that equation. y10 means when x is equal to 1, y is 0. So 0 when x is equal to 1, c1 plus c2 plus 3. So c1 plus c2 is negative 3, right? Okay. Now tell me how to find c1 and c2. We can't find, right? We have two unknowns, c1 and c2. And the first condition didn't help us, but it didn't provide us a mathematically contradiction, right? Mathematically 3 is equal to 3. So that's good. It was not like the first condition, the previous problem. In the previous problem, 7 was equal to 3. That's wrong mathematically. So we stopped there and said we have no solution. But here, the first condition gave us 3 is equal to 3. This is mathematically correct. And then using the second condition, we get c plus 1, c2 is equal to negative 3. Can we find c1 and c2? No. But at least we know one thing. What is it? c1 is negative 3 minus c2. Right? So instead of writing our solution just like this, we can write y is equal to c1x cubed. c2 is negative 3 minus c1. Let's see. Did I make a mistake here? Yeah, c2 is negative 3 minus c1. Right? So let's use in that way. So c2 is negative 3 minus c1. Okay. X to the 4 plus 3. So we cannot find c2, but we can say c2 in terms of c1. So we can still write the solution, but in terms of only one constant, without two constants. So here in this case, we do have solutions, but there are infinitely many solutions again, because we cannot find c1. This does not mean that you don't have solution. It says that we have infinitely many solutions. Okay. So the purpose of these 4 examples is that to show you we have a differential equation and you found the solution, and then depending on the boundary condition that is given, then you might be able to find several situations. In the first situation, we came up with a no solution situation, which provide you no way or mathematically doesn't make sense expressions. Second example, we saw that perfectly we can find a unique solution by solving for constants. Third example, again we saw that an expression where 7 is equal to 3 mathematically doesn't make sense, so we do not have a solution. Fourth example, we saw that in one of the conditions we get a mathematically making sense condition, but it didn't help. We still left with C1 and C2, but we were able to say that we have infinitely many solutions. So depending on the boundary conditions you have, you can get these three, one of these three things. Okay. All right. Yeah. So that's the discussion. Thank you.